Hello, Professor and TAs. Our group member is Jiwei Xia, Juan Li, Yishu Gu, and Weian Yang. Our project topic is called Scene Recognition with Bag of Words. We will examine the task of scene recognition starting with two different image representations, tiny images and bag of sift features, and two different classification techniques, nearest neighbor and linear support vector machine. We will classify scenes into 1 of 15 categories by training and testing on the 15 scene database. Here is a screenshot of our final result. It shows all correctly recognized scenes and the corresponding accuracy. Bag of words models are a popular technique for image classification inspired by models using natural language processing. The model ignores downplays word arrangement and classifies based on histogram of the frequency visual words. The visual words vocabulary is established by clustering a large corpus of local features.
We implemented two different image representations, the tiny images and sift features. The tiny image feature is one of the simplest possible image representations. We resize each image to a small fixed resolution. We generally recommend 16 × 16. It works slightly better if the tiny image is made to have zeroing and uniqueness. The sift is used to detect and describe local features in images. In the program, for each image, we densely sample merely sift images, but instead of storing hundreds of descriptors, we simply count how many sift descriptors fall into each cluster. In the project, the first method uses tiny image representation, and the second and third use sift representation.
We used two classifiers for training and testing. The first one called nearest neighbor classifier, which is based on closest training sample in a feature space. For example, the green circle in this picture is test sample, which should be classified either to the first class of blue squares or to the second one of red triangles. If k equals to 3, it is assigned to the second class because there are two triangles and only one square. For implementation, we use MATLAB built-in function WHEEL_OUTDIST2 to get distance between test and training samples. We assume k equals to 20 and classify our text sample to the category which has the maximum number of training samples in its nearest k neighbors. We use SVMs as our second classifier. We directly formulate and find a hyperplane that separates the data. An SVM training algorithm builds a model that assigns new text sample into one category to all the other, making it a binary linear classifier. In our program, we use a built-in function called WHEEL_SVM_train. This function will train linear classifiers to predict the category of every test image based on training samples. Every test feature will be evaluated with all 15 SVMs, and the most confident one will win. We assume lambda is 0.001.
A confusion matrix is a specific table layout that allows visualization of the performance of an algorithm, typically a supervised learning one. Here is a sample result of confusion matrix from our project. The x-axis represents the actual input and the y-axis is the test results or the guess of our classifier. As a result, we just need to look at the diagonal. If the color is bright rather than blue, it means our prediction is relatively accurate. Here is an estimated accuracy for 3 ways. For tiny image representation at the nearest neighbor classifier test, we got an accuracy of 22.1%, which expect to be around 18% to 25%. We wrote a function which produces a website containing all our prediction for each testing image. Here is a screenshot of the web page. For bag of sift and nearest neighbor classifier test, we got an accuracy of 51.7%, which expect to be around 50% to 60%. For bag of sift representation and linear SVM classifier test, we got an accuracy of 62.9%, which expect to be around 60% to 70%. By comparing the accuracy of the three type of tests, we find that bag of safety representation and linear SVM classifier test is the most accurate of the three. That's all our demo. Thanks for watching.